given is the 5.6 gram of NaCl and 218 milliliter of water. In finding the freezing point, you need to use the formula delta T F, which is the how much the freezing point goes up by, equal to Kf, the freezing point elevation constant, multiplied by molality. It is given that the Kf of water is 1.86 degrees Celsius per mass, but the molality is not given, and we need to find its value. We need to use the formula mole of solute over the kilogram of solvent. But in the given, the solute is converted into gram, so we need to find the mole of NaCl. By converting gram into mole, we need to know that 1 mole is equal to 58.4 gram. That makes 5.6 gram of NaCl is multiplied by 1 mole over 58.4 gram. Let's add all the gram. 5.6 multiplied by 1 is 5.6 mole, divided by 58.4. That makes 0.096 mole. But remember that NaCl is not 1 mole, because Na and Cl is equal to 1 mole and 1 mole. NaCl is equal to 2 mole. That makes 0.096 will be multiplied by 2 mole, so it can be 0.19 mole of ion. Now we have already found the mole of NaCl, 0.19 mole. The next thing we need to find is the kilogram of solvent, because the solvent is written as milliliter. Remember that 1 milliliter is equivalent to 1 gram, and 1 gram is equivalent to 1,000 1 kilogram. 1 kilogram is equivalent to 1,000 gram. 2.18 milliliter can be written as 218 milliliter can be written as 218 gram. And by converting gram into kilogram, we need to multiply it by 1 kilogram over 1,000 gram. Cancel the gram. That makes 218 gram equal to 0.218 kilogram. Now we have already found the milliliter of solvent. Let's find the molality. The mole of solute is 0.19 mole divided by the milliliter of solvent, the kilogram of solvent. That means 0.19 mole divided by 0.218 kilogram. This is equal to 0.9 mole per kilogram. Now we have already found the molality. Let's proceed in finding the freezing point. Delta F is equal to Kf multiplied by molality. Kf is 1.86 degree Celsius over mass multiplied by 0.9 mass. Cancel the mass. That makes the 1.17 degree Celsius. 1.7 degrees Celsius is the freezing point of pure water. The presence of solute in the solution will always cause the freezing point of pure solvent decrease. To make the freezing point of solute, we need to subtract the 0.0 degrees Celsius minus 1.7 degrees Celsius equals to negative 1.7 degrees Celsius. The given are the 17.4 gram of sucrose and 949 gram of water. In getting the molality, you need to use the formula mole of solute over the kilogram of solvent. We all know that the solute is the sucrose and the solvent is the water. To find the molality, you need to convert the gram into mole and the gram of solvent into kilogram. Remember that the 1 gram is equivalent to 1 mole, while the 1 kilogram is equivalent to 1,000 gram. 17.4 gram of sucrose is the same as 17.4 mole of sucrose. Converting gram into kilogram makes 949 gram of water multiplied by 1 kilogram over 1000 gram. And 149 gram is equivalent to 0.95 kilogram. That makes this kilogram of solvent 0.95 kilogram. We have found the mole of solute and kilogram of solvent. 17.4 mole of sucrose divided by 0.95 kilogram of solvent is equal to 18.3 mole per kilogram. Now we have found the molality. Given are the initial gas compressed equal to 23.0 milliliter, and the final gas compressed is 94.0 milliliter. The constant temperature is negative 273.15 degrees Celsius, while the external pressure is 0.98 atmosphere. First, let's solve the heat. By taking heat, we need to use the formula delta H equals to Q, which represents the temperature, the heat, the temperature multiplied by pressure. Temperature is negative 273.15 degrees Celsius multiplied by 0.98 atmosphere. It makes negative 267.69 atmosphere Celsius. Now let's proceed to work. Work use the formula W equal to negative P, or negative pressure, and delta V. We can get the value of delta V by subtracting the final gas compress in initial gas compress. Work is equals to negative 0.98 atmosphere multiplied by 94.0 milliliter, so minus 23.0 milliliter. Negative 0.98 atmosphere multiplied by 71.0 milliliter. That makes 71.0 milliliter the value of delta V. Negative 0.98 atmosphere multiplied by 71.0 milliliter is 69.6 atmosphere milliliter. In work, you need to convert atmosphere milliliter into joules. Let's convert the 69.6 atmosphere milliliter into joules. Remember that 1 liter atmosphere is equal to 101.3 joules. To get the joules, we need to convert milliliter into liter. 69.6 atmosphere milliliter multiplied by 1 liter over 1000 milliliter. Remember that 1 liter is equal to 1000 milliliter. Let's go back. If we multiply 69.6 atmosphere milliliter by 1 liter over 1000 milliliter, we can get 0.696 liter atmosphere. Now we already have liter atmosphere, so we can convert it into joules. 6.696 liter atmosphere multiplied by 101.3 joules over 1 liter atmosphere, let's cancel this out, is equal to 70.5 joules. Now we have found the work. Work is equals to 70.5 joules. Now we can get the internal energy. Internal energy, use the formula delta U is equals to Q minus work. Q is the change in heat. That makes the Q negative 267.69 minus work is equals to 70.5. Negative 267.69 minus 70.5 is equal to negative 338.19 joules, because the unit of internal energy is joules. Now we have found the heat, work, and internal energy.